able to cut. We need other volunteers. So you guys, you can help us with cutting the videos in 7 minutes, 7 minutes. But that's fine for now. Let's first focus on the. Are you able to see my screen? Are you able to see my screen?
Yes, sir.
We are able to do it.
Okay. So now what we do is we're going to start looking at, let's say, some quadratic functions. Let's say you are given a function f of x given by, let's say, x squared minus 4x plus 3. So this is what usually you guys call quadratic function. So if you ask to evaluate, let's say, f of 2, what will you do if you ask to evaluate f of 2?
We substitute 2 where x
You
is.
substitute where there is x by 2. So let's say here is 2 to the power 4, then minus let's say 4 times 2, and then plus 3. So that's going to be 4 minus 8 plus 3, and then the answer is 7 minus 8, which is minus 1, right? So that's just a way to evaluate the function. So if you evaluate the function at a number, that is fine. So which means that you can literally also, instead of evaluating the function at a number, you can also evaluate it at a letter. So let's say when x is equal to let's say alpha, you can literally also evaluate f of alpha. Then f of alpha will just be alpha squared minus 4 alpha plus 3. And then with that in hand, you can also evaluate, let's say, at x equal to alpha plus h, you can also evaluate f of alpha plus h or f of a plus h. And then you just means you replace x by, let's say, alpha plus h squared minus 4 times alpha plus h, and then plus 3. Then you can break it down using the normal identity. The normal identities are when you have x plus y squared. So we are taught clearly in the high school that this can be actually evaluated using some identities, which is given by, let's say, alpha squared plus 2 alpha times h plus h squared, then minus 4 alpha minus 4h, and then plus 3. Now, so you can see that for a function, then you can also evaluate f of alpha plus beta plus h, and so on and so on and so forth, f of minus 3, f of 0, and so on and so forth. So this is basically a way of saying that when you have a function f of x, you can put anything inside the input as long as the input is inside your domain. So I haven't spoken to you about the domain yet, but this is as long as your function is within whatever that you put inside is within the domain, then you should be fine. Then minus 4 alpha plus 4 minus 4h plus 3 plus h squared. So then that is the function that we are evaluating at f of alpha plus h. Now with this in hand, then we can also evaluate the something else. You see, we have evaluated f of alpha, and then we have evaluated f of alpha plus h. Then we can also try to see that you can also evaluate f of alpha plus h minus f of alpha, right? So that is another way of seeing it. And then when you substitute, if you look at f of h plus alpha, it was alpha squared plus 2 alpha h, let's say, plus h squared minus 4 alpha minus 4h, and then plus 3. Then f of alpha is become minus alpha squared. Let me go and check f of alpha. Minus alpha squared. So minus plus minus is become a plus, plus 4, let's say 4 alpha, and then minus 3, right? You can check if there are some issues, you will check. So this will just be equal to alpha squared minus alpha squared can cancel out. 3 minus 3 can also cancel out, right? So we have 3 minus 3 alpha squared minus alpha squared. Then let's look what else can cancel. 4 alpha and then minus 4 alpha can also cancel out. So we left with 2 alpha h plus h squared minus 4h. These are the one we left with. So, and if we now take f of alpha plus h minus f of alpha, then we divide it by h. Then we can see that if we divide by h, this will just be 2 alpha minus 4 plus h, right? If we divide both sides by h, so it become another number which is known as 2 alpha minus 4 plus h. Then this is what usually you call first principle, and we're using it just to introduce the notion of derivative. Now, uh, do you guys have any issues in the simplification? I just divided by h both sides, right? Then I wrote just the simplified version. Is there any issue like that for that? Now, in addition to that, which means for a functions, when I started by writing f of x. And then I also evaluated f of 2, then f of alpha, then f of alpha plus h. Then I took f of alpha plus h minus f of alpha. Then I took f of alpha plus h minus f of alpha divided by h. So which means that the variable can actually even be anything. If you check alpha can take any other values, is the constant, you can fix it, or you can actually also vary it, take different values. The same for h. So in the same venom, if someone write a function, let's say by g of let's say g of a, let's say g of a given by let's say a squared plus 2a. So that's the function where a is in the domain. So basically that's the function. I can literally ask you to evaluate g of 2, g of 3, g of 4, g of 5. So for homework, I'm going to say evaluate g of 2, evaluate g of minus 2, evaluate g of minus 1, evaluate g of 0, and then so on and so forth. You can also evaluate g of 3 and g of 4. G of 3, evaluate g of 1, and then evaluate, and the last one is you evaluate g of 4, or g of minus 4 inside. So you can see that is uh, because given any variable, if I can say given a function f of a given by a squared plus 2a, I can ask you to evaluate any I can check a to be taking any values as long as the a and the a is in the domain. For this case, when you look at g of a equal to a squared plus 2a, a can be anything. A can be any positive number, it can be any negative number. So which means that the domain is the set of real numbers. So from negative infinity to positive infinity. That's why I've been popping in values like minus 2, 2, minus 1, 0, 1, and 4, and minus 4, and so on and so forth, right? So which means that you can put any input, any real number can be an input, and then your output will be again another real number. So the domain is a set of all real numbers, and the range is a set of odd numbers. That's all I wanted to say. If you evaluate you try to compute g of 2 until g of minus 4, you'll find that you get different numbers. Can be positive, it can be negative, it can be even a 0, and then those numbers belong to the set of real numbers. So which means that you can pop in any number, it will still, the output will also be a number. So that means that the range is the set of all real numbers, and the domain is also the set of all real numbers in those instances. However, uh, we can twist it from the last time what we did. We can twist it slightly more, and then when we put the square root, then we'll see that the range might keep some of what you call some of the info, but the domain, I mean the domain might keep some of the info based on the restriction, and the range might change it generally to either from 0 to infinity or something like that, generally, more or less. Now, the most common point last time you asked, some of the students asked, was that why do you see one of the property, if let's say for the one I gave you, g of a equal to, let's say, I can't remember, a squared plus 2a. If I ask you to factorize, it's just going to be a times a plus 2, right? So yes, it's part of these things. Why we give mark for the factorization? Because we need those when we try to, let's say, when we try to solve, or when we try to sketch the graph of the function g, right? For you to sketch the graph, there are let's say, there are several possibilities. I can literally ask you to say solve, because I can see that this is very easy. For you to sketch the graph, you have something called intercept. that you must always need to figure out. Intercept is x-intercept is when y is 0, and y-intercept is when x is 0. So to sketch a graph, you need a two-dimensional space, which is you take the set of real number vertical and the set of real numbers horizontal. So this ones you call it x, and this ones you call it y. Generally, this is what you are used to in high school. However, depending on the value here. So let's say if I ask you to sketch g of a, I say solve. I can literally ask you to solve g of a equal to -1, right? So if I ask you to solve g of a equal to -1, how would you solve it? So you have several options. One option is to sketch the graph of g. Basically here, what am I saying? G of a, g is the function. G of a is the function g, right? At a. And equal to -1. -1 is another function which is called the constant function. So generally, the easy way to do is you take when the g is on the y value. So basically here, for you to solve, you must know that this one is actually the y value. So if you take g of a equal to -1, you must try to think that y equal to -1. So that value is supposed to be on the y-axis. So if I want to say, okay, in the y-axis, this is -1, then this is the graph -1. So that's what it means is I'm taking the graph of g and then I'm comparing it to the graph of -1. The graph of -1 is just -1 all over. For any value of x, y is always -1. When x is 0, y is -1. X is 1, y is -1. X is -1, y is -1. X is million, y will be -1. So it's the constant function, it won't change. However, the g of a, is the function where change. So you can call it g of x if you want to. So you see at a equal to 0, you will see that g of a is also equal to 0. That gives you one intercept, right? However, at a equal to -2 is 0. So that gives you the second intercept, right? So basically, you already have an idea. So which means that one intercept will be at 0. The next intercept is at minus, so in the x value. So is at, let's say, -1 is there, -2 is there. And then the second one is when you try to look for the turning point for this graph. So generally, why I did the first principle is for you to have an idea of what the turning point. You take, let's say, g of a plus h minus g of a divided by h, and you try to see how is that one going to look like. So it's generally called a turning point. Now, another way of let's say another way of you figuring it out, that so you see the graph actually passes via this, passes what you call via this point. So you have two options. One way you say you can solve it in this way. One way you can say, okay, that is one way to draw the graph of -1 and the graph of g of a. Another way is you take g of a equal to -1. It implies that g of a plus 1 equal to 0. But g of a is a squared plus 2a plus 1 equal to 0. So when you look at it in this way, the new graph, if you take it back to the remarkable identity that I just said, is a plus 1 squared equal to 0. So in a way, it's just a plus 1 equal to 0. A plus 1 equal to, sorry, a plus 1, but I wrote a equal to 1. A plus 1 equal to 0, or you write it as a equal to -1, right? That's another way of looking at it, right? And then if you pop in, let's say, if you come here, you want to sketch the graph. So you see, if you want to solve, let's say, g of a equal to -1, basically, what does it mean solve g of a equal to -1? Another way of writing it is that find the value of a for which g of a equal to -1, if you want to look at it. So when you get a equal to -1, you substitute this inside. So verification, g of -1 will be -1 squared plus 2 times -1, right? That is going to give us -1 squared is 1, plus 2 times -1 is -2, and then the answer is -1. So g of -1 is indeed -1. That gives you for a equal to -1, g of -1 equal to -1. That's the algebraic option, which is usually the easiest way. For you to solve this, you don't need to follow this technique. You can use the quadratic formula if you want to. So at home, then I'm going to give you another option. Let's say solve as a homework. Uh, Solve, let's say g of a equal to 3, g of a equal to -3. So you have various options to solve it. So as you visualize using the two graph, you already know how to get the graph of g of a because I already got for you the two intercept. The moment you have the two intercept, then to draw a quadratic function should be a straightforward. Great. Now another way of saying in the high school, that let me try to bring it back. You see, I gave you at the beginning, calculate g of 1, g of -1. You see, in the high school, usually what you do is you do something like this. You say this is x, and then you say this is y. So you give x and y different values. If I remember, you can start by 0, -1, -2, -3. Then let's say 1, 2, 3, 4. You give several values, and then you try for x. That is your a. Y, it will be your g of a or g of x. Then you calculate for all these values that I've given you there. You calculate this, and then you try to look at how the graph. So then you can sketch every couples, and then it gives you an idea how the graph will look like. So that is another way of sketching the graph, right? Now, one other way of this is you call it finding the equation of a function. So let's say if I give it to you in terms of let's say a and b, and then if I ask you find the function f of a, that means that generally you have to solve and find for those values. However, in this class, usually generally we can perhaps you see for some of the functions they are a bit tricky in a sense. Let me try to come here. If let's say generally most of you know that these things like this is what you call is not a d, is like a uh, if this is the x and then this is the y axis, so it's half a circle or quarter of a circle and so on and so forth. It could actually also be this way, or it could actually also be this way. So now if that's the unit circle, let's say here is 1, -1, -1, 1, the same here, -1 and 1, and so on and so forth. Generally, it comes from the function x squared plus y squared equal to 1. I think for those who haven't submitted their assignment, uh, they will already be like, doing their hand like this, say, that's something close to what we have in the assignment. No, I'm not explaining what you have in the assignment, but I'm explaining the things that you're supposed to have an idea of in terms of a function. Because we are now in the chapter of function, I'm trying to create. Is this a function the way it is? Can someone tell me, is it a function, yes or no? If I have x squared plus y squared equal to 1, is it a function, yes or no? We have seen the definition of functions last week, right? I'm trying to ask you, is this a function, yes or no? Guys, am I audible enough? It seems like, let me go and check. Maybe I'm not in the meeting. Hello, guys, are you able to hear me? Please
Yes.
put a thumb up. Okay, thank you. Thank you, fully fellow. Yes, if I'm audible enough, I'm asking, is this a function, yes or no?
I think so.
What do you mean you think so? Okay, how did I define a function last time? So let's take it in a practical form. Let me just try to recall what I said last time. I said we have a set of input x, which you call a domain, and a set of output y, which usually you call the range. And I say here you have, let's say a, b, x, small x, or maybe let me call it c and d. You see, on this side you have f of a, f of b, f of c. So if it happened that for one value you have for a and b, you have f of a and f of b is the same. Is that a function, yes or no? From what we have seen last week, we said this is a function. Now, if it happened that, let's say, f of c goes there, and then f of d goes to there, and then f of d goes to also here. F of d has f of d, not f of b, has two different values. I say, is this a function, yes or no? The answer is no. You see, for one value d, you cannot have two different values, f of a and f of d, so it makes it not a function, right? Now let's look at the circle in that sense. If we're trying to look at that circle that is given x squared plus y squared equal to 1, this is how it looks like. So if I pick an x here, let's say x equal to negative half, right? For x equal to negative half, how many values goes to the circle? There are two different values for that value of x, right? So the one value is this y value here, and the next value is this y value here. One value is negative and another value is, I'm going to call it minus alpha, and this is, I'm going to call it plus alpha. You see, if you take that function that for one x equal to negative half, you get two different values, a negative value and a positive value, then this is not a function, right? So the square is not a function. Now the question is that how do we make it a function? So if you take that square, let's say x squared plus y squared equal to 1, then you can write it as y squared equal to 1 minus x squared. Then by taking the square root on both sides, then the left hand side become plus or minus y, and the right hand side just become the square root of 1 minus x squared. This one we didn't simplify it. Then if we're trying to now simplify it further, we have two different functions, y equal to square root of 1 minus x squared, and another one y equal to minus square root of 1 minus x squared, right? So you see now, each one of them separately is a function on its own. One is for the y that is positive, and another one for the y that is negative. So and now here, the first one is a function on its own, the second one is a function on its own. But the way they are at the start, x squared plus y squared equal to 1 is not a function. So all right, now that we have seen the difference, what makes it a function or not, so we should know that when we have what do you call it, when we have let's say, when we have how do I call it, when you have how do I explain, when you have a function that is given to you from which you identify if for one values of x you have let's say two different values of y, that makes it not a function. However, if for one values of x you have one value of y, or for one value of y you have two x's coming to it, that makes it a function in a sense. Let me go and take some hands. Any questions before we move further? Guys, any question? I'm not sure if people are in this meeting though.
No question further, sir.
Okay, so if there are no questions, then we're going to move to what is it called, to evaluation and functions of, what do you call it, composition functions, right? All right, so now I assume that from now going onward, you guys should be able to solve any function f of x equal to y, or f of x equal to z or something, and you should be able to identify. Again, I mentioned that a circle is not a function, and then I just gave you the case where the function is. I said that for this one, I said that x squared plus y squared is not a function. However, if I take y equal to square root on its own, 1 minus x squared, this will be a function. So then as a homework, I'm going to say sketch. Sketch, maybe I'm going to call it, instead of calling it y, let me call it h of x. Great. Okay. Now let's see in terms of if I'm going to let's say give another different type of example. So let's say it's not generally that always you get it in algebraic form. Sometimes you can also get it not necessarily in an algebraic form, right? So let's say if I give you something like this. In fact, let me draw it with a different color because so if I give you, let's say, a function, it's a graph of this nature. Is this a function, yes or no?
It's not a function.
It's not a function. Why? Because for one values of x, you can literally get several values. Now I'm going to take another one. So let's say I'm going to take, instead of this one, I'm going to take another one like this. And then let me sketch the xy values. Let's say, is this a function, yes or no?
Yes, it's a function.
Yes, it is a
Yes.
function because you can get so many values of let's say x giving you the same. And an ideal example would be, let me take the red color. An ideal example will be, try to look here where there are this intercept. What is the value there? If you can just by just inspection, what is the value? The value there is what? X. For x you can forget it, but for y, the y values is the y value
Zero.
is 0. The y value
Zero.
is 0. So you see that if the y value is 0, then there are two different x values that giving you 0. So which makes it a function, is satisfy that previous definition. All right. So it means that now you have generally more or less an idea of what a function is, and generally which I just gave you some specific types of functions, not necessarily that all the functions are of this type or of this nature. You can get functions of something of that type. You can get something that is like this going that way. Additionally, you can get something, let's say, from up going down and going this way, and so on and so on and so forth. So the list is quite long. Okay, there are other type of function which usually they call them absolute values. So I'm going to define. So the absolute value function. Let's start by f of x equal to this. So this double bars, they call them absolute value functions, right? So let's say we have absolute value function of x. Let's try. Uh, the absolute value function of x is always positive. So you mean that for any value that you pop in, for any x, let's say for any value, any input, we have that absolute value of x is always greater or equal to 0. So which means that it's a function that will always be positive. So what does it mean? It means in a sense, if I type absolute value of -2, I get 2. Absolute value of -3, I get 3. Absolute value of -4, I get 4. So then we're going to now define it in a different way. The absolute value of x is defined like this: is equal to x if x is strictly greater than 0, is equal to 0 if x is equal to 0, and is equal to minus x if x is actually strictly less than 0. So what does it mean? When x equal to 2, the absolute value of 2 is just 2. When x equal to 3, the absolute value of 3 is just 3. When x equal to 10, absolute value of 10 is 10. You pop in 100 is 100. When x is equal to 0, absolute value of 0 is 0. When x is equal to, let's say, -3, now the question is that what is the absolute value of -3? The absolute value of -3 become like this. By this definition, the absolute value of -3, it means that x is negative. So it's going to be -3. Then the answer become +3. You can see now that the absolute value of 3 is also 3. But the absolute value of -3 is also 3. So we mean that the absolute value is a machine that takes an input that either if it's negative or positive, but it transforms it into a positive of itself, right? Now, based on this, if we can pop in something like that, we say this is x, let's say this is y, which is the absolute value of x. Then for -3, I'm going to get 3. For -2, I'm going to get 2. For -1, I'm going to get 1. Why is my screen not working? For 0, I'm going to get 0. For 1, I get 1. For 2, I get 2. For 3, I get 3. For half, I get half. For 4, I get 4. So you see, now this is when I pop in 4, the output is 4. Input is 4, output is 4. Input is 3, output is the same thing. Input is 2, output is the same thing. Input is 0, output is the same thing. Input is 1, output is the same thing. Input is -1, output is 1. Then I'm going to say, okay, but then this is something that I can sketch very easy. You see, if I'm 0 is 0. If I'm 1 is 1. If I'm 2 is 2. If I'm 3 is 3. -1 is 1. -2 is 2. -3 is 3. So you see, then this gives me the sketch of the absolute value function. I can take it in red color. In red, I want to sketch it in red. So it's not 100%. So this is the one in red is the graph of the y equal to absolute value of x. Great. Now, with this in hand, so you can learn now what we call the I'm going to tell you what we call the horizontal line test. The horizontal line test is actually, in a sense, is the way to use it to test if a function is a function or not, right? So you see, when I draw as earlier on, let me come here. I'm going to repeat what I did earlier on. When I did like this graph, right? And I did also another one is like this. With the horizontal line test, you can let's say take it's just like a ruler. You see, when you are on a paper, I don't have a paper here next to me. When you're on a paper, usually, and you have a ruler, it's basically you have a graph there, and then you put a ruler straight, and then you draw a straight line, like we call a horizontal line test. Now, the horizontal line test is a way to determine if a function satisfies a certain rule. And that specific rule is called one-to-one. So I'm going to give first the definition of a one-to-one function before I can tell you how to use the horizontal line test. Now, a function f. So I'm going to say now definition. I'm not sure if it's definition number 2. I can just say a function f is a one-to-one function. Is a one-to-one function if f of x1 equal to f of x2, it implies that x1 equal to x2. Now, in mathematics, something that usually we call position, or something that usually we call logic. And now the question come in. You see, I started by f of x1 equal to f of x2. But if you take f of x1, you baptize it, you take it to the church, and you call it y1. And f of x2, you call it y2. So it's when y1 equal to y2, it gives you that x1 equal to x2. So you see, earlier on, I spoke about input. You start from input, you get the output. Input is in the domain, output is in the range. This time around, I did the opposite of to what I was doing from last week. Instead of me starting by the input, I started by the output, something that is in the range, and then I come to the back. I work backward to something that is in the input. So if f of x1 is equal to f of x2, it implies that x1 is equal to x2. Now the question come in. F of x1 is the part of the graph, because that is the y value. The y value is the one that helps you to sketch the graph, and that's the reason why the idea of horizontal line test come in. The horizontal line test is basically, if you have a graph, let's say you have a graph of this nature, right? Then you can use the horizontal. I think I might use yellow, I don't know, or red. The horizontal line test means that you can draw a line like this, straight, crossing. I can draw. Someone can draw in this place. Someone can draw it here. Another one can draw it here. Another one can draw it here. So is a line that for us to test if the value of f in the graph, if we have the same, will it give us the value of x also being the same? So basically that is the question. So which means that once you have the graph, you just sketch a horizontal line, and then the horizontal line, if any horizontal line intersect the graph more than once, let's say it touches the graph, if it touches the graph more than once, that means that the graph does not represent a one-to-one function, right? If it touches the graph more than once, the graph does not represent a one-to-one function. But if it touches the graph once, that means that the graph is representing a one-to-one function. Now, basically the mathematic that we did here, what does the horizontal line tells us? The horizontal line tells us that this mathematic that we did, the definition is saying that if f of x1 equal to f of x2 mathematically, then x1 is equal to x2. So it tells us that for us to by inspection, horizontal line is something that by inspection, just by looking at the graph, then I take my ruler and then I place my ruler. If I put the straight line there and then the line is touching the graph more than once, then that graph is not a one-to-one function. So the function that help us to sketch the graph, we say that that function is not a one-to-one function. So basically it's called an inspection technique. So it's just by looking at the graph, I can, even without even drawing the horizontal line test, I can just see that, oh, no, this one is not a one-to-one function. Now the question is that which ones are the one-to-one? Now, as I said that the horizontal line is it help you to just get that the function is not one-to-one. So the question is that how do you find out if the function is one-to-one? So now let's look at the circle, right? For the circle, obviously, because we said it's not a function, then there's no even need for us to test. Because even if you check the horizontal or vertical line, the circle you'll always be touching it more than once, right? So obviously, despite it being is not what do you call is not a function, is automatically even not a one-to-one. So that is without even the benefit of the doubt. Now the easiest option is let's start by a constant function. A constant function is that if I define, let's say I'm taking an example. If I take f of x equal to, let's say, 3, that's the constant function. You can call it a constant c. Or if I take f of x equal to 1, so by definition, this is a constant function. So how do, if you sketch it, when you draw the xy axis, let's say 0 is here, 1, 2, 3. Let's assume that 3 is here. So the graph is going to be like this. You see, if you sketch a horizontal line, the horizontal line passes straight through that graph, right? So basically, let me take something. If I take, let's say, the mathematic definition, let's say f of x1 is equal to 3. I pop f of x2 is also 3 because the function f of x is 3. Now the question is x1 equal to x3? Let's say you take f of minus 2 is equal to 3. Let's take f of 5 is also equal to 3. You see that f of minus 2, if u1 in reality, f of minus 2 is equal to f of 5. Can we say that 5 minus 2 is equal to 5? Can we say that? Remember the definition of a one-to-one. I'm giving you an example and counterexample so you can pick the definition of one-to-one. So now for the horizontal line test, when you look at it, when you test the horizontal line test on this function here, what can you see? The line passes through how many points? Infinitely many of them, right? If I test a horizontal line in red, passes via 3, right? That line actually touches them as many as possible. It touches the graph as many as possible, right? It touches the graph in several infinitely many. So it makes that this function is not a one-to-one function. Are you guys with me? Now I'm going to change slightly. Yes? Is someone saying something?
No, sir, I was saying we are with you.
Okay, now let me change slightly. So I'm going to take another function. I say, let's say f of x equal to, let's say, x. In fact, minus x. Just x is fine. Now let me take f of 1 is equal to 1. F of 2 is equal to 2. F of 3 is equal to 3. F of minus, let's say, 4 is equal to minus 4. Is f of whatever that you pop in there is equal to wherever that you pop in there. So the input is the output. It's not the same as the absolute value. We can see also the cases for absolute value, but this is slightly different. Now let's look at one thing. Now if I say f of x1 equal to f of x2, this is where I'm going to start with. Then the left hand side is x1, the right hand side is x2, and then the middle is equal. So it means that when you started f of x1 equal to f of x2, you started by f of x1 equal to f of x2, and then you ended up by having that x1 is equal to x2. So this actually function f of x equal to x satisfies the definition. Is there one-to-one function? I'm going to use some abbreviation. I'm going to say one-to-one. So that's what I mean by one-to-one function. Now we take another example. The one that we just take, let's say f of x equal to square root of, in fact, that is a bit difficult. Let's say f of x equal to square root of x. Now I'm going to start by popping, let's say f of 2 is the square root of 2. F of 4 is the square root of 4, which is 2. F of 3 is the square root of 3. Now I'm going to take f of 9 is 3. Now the question is, I'm going to take f of x1 is equal to f of x2. That's the hypothesis. It means that the square root of x1 equal to the square root of x2. Now, we want to see if the square root of x1 equal to the square root of x2, because, sorry, that is x2. I didn't write it correctly. So here I have square root of x1. I'm going to repeat equal to square root of x2. I can square both sides. You can square both sides. Then here I'm getting x1 equal to x2. So what happened is that we started with f of x1 equal to f of x2, and then we ended up by getting x1 equal to x2. Then it means that f of x equal to the square root of x is actually is a one-to-one function. Now another way of looking at it, so you can tell me that, oh, prof, sorry, sir, how is the horizontal line test coming into play? Now let's say we try with the first one. The first function is f of x equal to x. If you sketch when x is 1 is 1, when x is 0 is 0. So let me use a different color. So this is when x is minus 1 is 1. This is the graph of f of x equal to x, or you want y is equal to x. So now if you take the horizontal line test, you see that the horizontal line test is like you test it like this. Does it touch many times or does it touch only one? So if 10 of us sketch a line, 10 of us use the ruler, so which means it touches only once. It doesn't touch more than once. It touches the graph only once. Now let's go and see another case. Now if you see another case, let's say the second one was f of x equal to the square root of x. If you try to sketch this function starting here and going, now you're trying to use the horizontal line test. The horizontal line test, when it goes, it touches this graph actually only once, you see? If you draw so many horizontal line, you will notice that it's only touching the graph once. So it's just is the one-to-one. Now we take, let's say, something that is slightly, now a homework. F of x equal to x squared. G of x equal to the square root of x squared minus 1. Determine, or in fact, h of x equal to absolute value of x plus 1. Determine whether f, g, and h are one-to-one function. Great. Let me come and see if there are questions first. Any hands? Any hands is up, guys? Any question on one-to-one functions?
Okay, so say, according to my
Yes.
understanding, can I say a linear graph is a one-to-one function because the horizontal line touches only once?
And not necessarily, but for a linear graph is obvious because the graph doesn't have several. So that's why obviously that you can see that, okay, for a linear graph is a one-to-one automatically because the horizontal line only crosses one. Yeah. But the graph, the square root of x is not a linear graph. So in fact, basically, I see what you're saying. Yeah, when the function is linear, is automatically one-to-one. Yes, that is also true. Are you with me?
Yes, sir, I'm with you.
Yeah, okay. Uh, so yes, any linear graph it is, as you mentioned, is a one-to-one. But there are some graphs that perhaps also might be not linear. They also be one-to-one. So for your case, that let's say the square root of x is not linear because it's x to the power half. So obviously, it is not necessarily linear, but it's also a one-to-one, right? But you see that was a special case. So basically, you can also add 1 over square root as another function. All right. Any question, guys? Okay, I might
Can I
also
ask,
add for you maybe. Yes, go ahead. I'm adding
isn't
another
it
function. Yes. Yes.
isn't it
Sorry.
g isn't it g at x equals to the square root of x squared minus 1 also a linear function?
No, no, not linear because you see if we try to write it, if you have the square root of x, it's basically x to the power half. That's the same works for the square root of x squared minus 1 is actually x squared minus 1 to the power half. So basically, it's not necessarily a linear. It might behave like a linear when you look at it because there is an x squared inside the bracket and then there is a power half outside the bracket. So it looks like it is a linear, but it is not a linear. Not that is straightforward as linear
Uh,
as you mentioned. Yes. So in fact, maybe I should give more homework. Let's say take let's say f1 of x, let's say equal to let's say 2 over x, and then let's say f2 of x equal to let's say minus 2 divided by x squared, something like that. So these are various different type that you need to look into. Um, let's say I take maybe f3 f3 of x is another homework is let's say 1 divided by the square root of let's say x minus 1. So try to in each situation determine the domain, which is the most important one. Determine the domain, perhaps also the range if you want, but determine the domain and also find out if the function is whether it is one-to-one or not. Right.
okay.
Okay.
Sir,
Yes, go ahead.
sir, is it not possible if you can type it down and upload it on additional resources? Because I'm struggling to see your handwriting a bit.
Okay, no problem. What I will do is I'll upload it under the additional resources so that everyone can access it. Is that fine?
Yes, that's fine. And could you also upload the recordings from last week or any homework
Yes,
that was given last week? Because I didn't know there was class last week.
definitely. Most definitely, I will do that.
Okay, thank you very much, sir.
All right, you most welcome. Yeah. Okay, so any issue guys about functions? It should be straightforward. So basically, by just looking at the graph, you should be able to determine using either the vertical line or the horizontal line whether this graph is actually a one-to-one function or not. And then by just looking at the graph, also you should be able to. So now today we have seen the definition of the absolute value function. Last week we have seen the definition of the square root of x squared, and then I'm trying to see now if you guys you notice that there are relation between the two. So let's see. I said early on that absolute value of x is given like this: is x if x is greater or equal to 0, minus x is if x is less or equal to 0. I try to shorten it to make it short. Otherwise, I can remove the equal 0 part and then put a 0 in the middle, which is the same thing. Now look here when you see that the square root of something squared. That is actually absolute value of x in a reality, because it's actually I'm trying to reduce to what do you call it, to try to shrink the first definition so that you can see it's actually the same thing. So basically the square root of x squared and the absolute value of x is actually just the same thing. Now you should know going forward that there is no much of a difference between the absolute value. Now earlier on I showed you how you find the value of a function at a certain output or at a certain input, or you find, I mean, the value of the input when the output is given. So now based on that, if you are looking at a graph or if you are looking at a function, you can easily evaluate the value of a function at a given point. However, if you are looking at it, and then you can also sketch the graph because you can see that the function is given. However, if you are given a graph and you are working backward, you should also be able to use that either using the horizontal line test to say is a one-to-one, or either by just looking at the graph, by looking at the x value and the y value, by checking that, then you can find the value of that point, which will help you to find the x values. Great. Or if you are given a table, you should be able to actually sketch the graph. So now, going forward, in terms of domain, range, and function, and one-to-one function, we are settled, right? So another way of me saying is like, let's say there are some type of function I didn't ask you to find the domain. We did, but we did. Let's say I'm giving you a function called p1 of x, given by, let's say, x squared plus 2x plus 3. So I can literally ask you to find, let's say, the domain gp1, and also find the range, the rp1. So basically, it's another homework. I'm not sure. I hadn't give it to you the last time. Then perhaps maybe the way of sketching the graph. So I think in terms of sketching the graph, I don't think you will have an issue. But then there are some certain type of a function that we didn't speak about a lot, the rational functions, which also part of the function. You see, there's a certain type. I only gave you 1 divided by x, and I ask you to find the domain. But then let's say if I take g of x, let's say equal to x divided by, let's say, x plus 1. Or let's say I take h of x equal to, let's say, minus x divided by, let's say, x squared plus x. Minus x plus 1. In fact, I should take minus x plus 1 divided by x squared plus x. Or there are certain type of function where you're supposed to know that for you to determine the domain. We did see how you find the domain last week. And then from the domain, you should be able to also sketch the graph and also determine the range. So I'm going to say for the above function, find the domain, let's say, find dg, and then find also dh, and find also rg, and also find rh. For rh for the range of h, and then rg is for the range of g. Great. I think apart from that, any other question that you guys need to ask in terms of domain and range? before we can move to some. Oh, in fact, we reach our time. But just any other question? Okay. If you don't have a question, then maybe perhaps I should say we'll stop here so that I can do the admin part to upload some of this recording. The previous recording, I was waiting for Visar to. Remember, we have taken Visar last time, and we asked him to actually cut the recording into 7 minutes. But I think he's still busy with it because he said he had a work. He might not be able to finish. So, however, if he finish and get back, then I can upload all at once. However, I was actually thinking of uploading the link to the recordings, to the Teams recording, so you guys, you can access it while we are waiting for the recordings to be cut into small pieces. Is that fine?
Yeah, it's fine.
Okay, excellent. Let me see if there are any other questions. Otherwise, we can end up the discussion today here. Okay, guys, do you have any other question? Do you think we schedule another discussion tomorrow or the day after? Because today I was caught by surprise that I have like a 5 hours meeting that, in fact, I just finished before I can join you guys. So unfortunately, I couldn't be on time because I had to go and give a presentation there. Please, any other question, guys? Today, unfortunately, we have very few. It seems like having the discussion early in the morning is the best solution, right? So maybe I should put it at 8 o'clock or at, or I don't know, at 9 or at 10, something like that.
Make it
What
10.
do you guys? 10 o'clock in
think
the morning. Okay, so the last one we had was 9. So let's see. Let's try to make it 10. I'm not sure if I'll be able to make it tomorrow. If it's not tomorrow, then the day after. So if I can't make the discussion tomorrow, then the day after I should be able to make the discussion so that or maybe on Thursday. So I'll try to see if we have maybe two or three discussion during this week so that we can push this chapter, and then we should be able to, so that the students are able to submit their what do you call their assignment and be prepared in the meantime. Any other question, guys, before I stop the recording? Hello,
Not on my
guys, are you okay? All right,
yeah.
guys, if there's no
Yeah.
question, then I'm going to stop the recording. We stop for today, and then maybe perhaps if I can be able to make another discussion